Good morning, everyone. We are back with the third session of the Triangles chapter for class 10. We have done the difference between congruency and similarity. We have done the basic proportionality theorem and its converse. We have also used both the theorems to complete exercise 6.2. Now we'll be doing what are the various axioms of similarity, what are the various ways we can prove the triangle similar, and use that knowledge
to do up exercise 6.3.
In the previous section, it was stated that two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio or in proportion. That is, if I take triangle ABC and triangle DEF, they both will be similar if angle A is equal to angle D, angle B equal to angle E, angle C equal to angle F, and also I have AB upon DE equal to BC upon EF, which will be equal to AC upon DF. If all these six conditions are fulfilled, we have done that the triangles are going to be similar. But my dear children, even without proving all the six conditions, if we are able to prove a few important things correct, then also triangles are going to be similar. So what do we have? Let us discuss the criteria for similarity of triangles. Theorem 6.3, if you take, it says that if in two triangles, if corresponding angles are equal, then their corresponding sides are in same ratio and hence the two triangles are similar. What do you mean by that? That if in case I have a triangle ABC and triangle DEF, said that the angles of triangle ABC are respectively equal to angles of triangle DEF, in that case, automatically the sides will also come out to be proportional and hence the triangles are going to be similar. Or else, even for that matter, if two angles of one triangle, see if I have angle A equal to angle D, angle B equal to angle E, automatically by the angle sum property, angle C would be equal to angle F. So it is not even the three angles that are required to be equal. Even if if two angles of one triangle are respectively equal to two angles of the other triangle, then the two triangles are similar. This may be referred to as AA similarity criterion for two triangles. Let us understand this by another GeoGebra applet. Let us see this GeoGebra applet. If in case I move this such that the angles are still the same, the angles are still remaining same. If I move any one of the vertices, then the ratio of the sides, if you see here, if I have this sides such that, see, this is 9.5, this is 19, this is 12.8, this is 25.6, this is 9.2, this is 18.4. So the ratio is how much? 1:2. Now I start moving these vertices such that the angles remain same. Let us check whether the sides are still in proportion. 6.2, 12.4, 1:2 ratio. 10.5, 21, again 1:2 ratio. 9.2 and 18.4, again the ratio remains same. So if I'm dragging one of the vertices, any way I drag, if the angles are not changing, you see the angles are still remaining the same. If the angles are same, the ratio of the side 9.2, 18.4, 15.3, 13, 30.6, 8.9, 17.8, the ratio of the sides is also remaining the same. Let us come to the second criteria now.
If in two triangles, sides of one triangle are proportional to the sides of other triangle, then their corresponding angles are equal and hence the two triangles are similar.
This criterion is referred to as SSS Similarity Criteria for two triangles. That means that we do not even need the angles at all. Just in case we have the sides of one triangle proportional to respectively sides of the other triangle, then automatically the angles will become equal and hence the triangles are going to become similar. Again, to prove this, let us take help of the GeoGebra. Here if you see the sides and the ratio 1:2, 7, 14, 1:2, 10 and 20, again ratio 1:2, 8.5 by 17, again the ratio is 1/2. So if in case I move them, if I drag these, you'll see that the angles are also remaining same. I can check the value of this angle and this angle, they'll remain same. Value of this angle, you can also see it's very clearly, it's visible. These angles will also remain same. So if this ratio is same, again, if you take the ratio, I just extend this, keeping ensuring that the sides are changing. So this is 13.9, this is 27.8, ratio is 1 is to 2. This is 8.5, 17, ratio is 1 is to 2. 20.1 and 40.3, again the ratio is 1 is to 2. So then you can see that if I take a protractor and I try to measure, the angles will remain to be as same. Come to the third criteria, the theorem 6.5. If one angle of a triangle is equal to one angle of another triangle, then the sides including these angles are proportional, then the two triangles are similar. That means we just don't even need three sides or three angles. If we have two sides proportional to the two sides of the other triangle and the included angle is same, then also the triangles are going to be similar. Again, this is referred to as SAS. So we have done the three criteria. The first one was AA or AAA criteria. Second one is SSS SSS criteria. And this third one is the SAS criteria for similarity. Again, let us use the GeoGebra to find it out, to check this. I'm just dragging this orange one. If I drag this, you see here, the sides are remaining in the same ratio. This is 8.5, this is 17, this is 15, this is 30. The angle in between these two sides is 40. You can see that one triangle is exactly the enlarged image of the smaller one. They are just the same. They are not different. They are going to be similar to each other. This angle will be equal to this one. Also, this side, if you measure, this QR upon MN will also come out to be how much? 2 is to 1 as the ratio of the other sides, and the triangles are going to become similar. So let us go back once again to the PPT. The students, as we know, different criteria for similarity now. Let us solve some examples based on the same. See the example 5 we are doing. Observe the given figure and find angle P. Look here, we have what? This is how much? Ratio is 3.8 and 7.6. What is the ratio? 1 is to 2. 3.3 root 3 and 6 root 3. Ratio is how much? 1 is to 2. 6 and 12. Ratio is again 1 is to 2. That means the triangles are similar. Now keep in mind the correspondence. If you go from 3.8 to 6 to 3 root 3, AB 3.8. So again, I'm going from 3.8 to 6. So I'll have to go from 7.6 to 12. So triangle is going to be triangle ABC will be similar to triangle RQP here. All right. And then I can find out the value of angle R will be equal to angle A, angle B will be equal to angle Q, and angle C will be equal to angle P. So I just wanted to find out angle P. By the angle sum property, I can find out this is 80 plus 60, this is 140, so this will come out to be 40, so angle P will also come out to be 40 degrees. It is done for you. The ratio is same. Thus, by the SSS similarity criterion, the triangles become similar. This is symbol for similarity. When I say the triangle similar, I use this symbol. Therefore, angle C is equal to angle P by the corresponding angles of similar triangles. You can write CPST, corresponding parts of similar triangles. The way we used to write CPCT, corresponding parts of congruent triangles. Same way we write CPST, corresponding parts of similar triangles here. So by angle sum property, we can calculate the value of angle C, which comes out to be 40, and hence angle P is also equal to 40 degrees. Now example 6, let us take. Figure 6.31 is given to you. OA into OB is equal to OC into OD. I need to prove what? I need to prove that angle A is equal to angle C and angle B is equal to angle D. OA into OB is equal to OC into OD. If I rewrite it as OA upon OC is equal to OD upon OB. So I get OA upon OC is equal to OD upon OB. And I already have this angle AOD equal to angle COB because of the vertically opposite angles. Therefore, by the SAS similarity criterion, so I have OA upon how much? OC is equal to OD upon OB. Corresponding sides are equal, are proportional, and angle AOD is equal to angle COB. Therefore, the triangle similar by the SAS rule of similarity. Hence, angle A will be equal to angle C and angle D will be equal to angle B. Example 7. A girl of height 90 centimeters walking away from the base of the lamp post by at a speed of 1.2 meters per second. If the lamp is 3.6 meters above the ground, find the length of her shadow after 4 seconds. So what do we have here? Let AB denote a lamppost and CD be a girl. After walking 4 seconds away from the lamppost, let the distance DE be how much? X meters. Then BD will be how much? BD will be equal to 1.2 into 4. So the speed of the girl is how much? 1.2 meters per second, and time taken is 4 seconds. So distance traveled will be equal to speed into time, which is equal to 4.8 meters. Now note that in triangle ABE and CDE, compare triangle ABE and CDE. This is 90, this is also 90, and this angle E is the common angle. Therefore, the triangles are similar by the A criterion of similarity. If the triangles are similar, will the sides be proportional? Yes, the sides are going to be proportional. So, since I can say DE upon BE will be equal to CD upon AB, and I can find out the lengths using the formula 4.8 plus x upon x is equal to 3.6 upon zero point 0.9, which gives me x is equal to 1.6 meters. So the shadow of the girl after walking 4 seconds is 1.6 meters long. See the eighth example now. In the figure 6.33, CM and RN are respectively the medians of triangle ABC and triangle PQR. If triangle ABC is similar to triangle PQR, prove that triangle AMC is similar to triangle PNR. First part. Second one, CM upon RN is equal to AB upon PQ. And third part, triangle CMB is similar to triangle RNQ. Now, first of all, just see here, it's given to me that ABC is similar to ABC, similar to triangle PQR. That means that angle A will be equal to angle P, angle Q will be equal to angle B, and angle R will be equal to angle C. Also, AB upon PQ will be equal to BC upon QR will be equal to CA upon RP. These are the 6 things that I'll get. Now, what is given to us? AB is twice of it, since CM and RN are the medians. So, can I say that AB is twice of AM and PQ is twice of PN? So, that means instead of writing AB and PQ, AB upon PQ, and I can write 2AM upon 2PN, which is equal to CA upon RP. So I have got twice of AM upon twice of PN is equal to CA upon RP. Now this 2 and 2 cancels, and I am left with what? AM upon PN is equal to CA upon RP. Also, I know that angle A is equal to angle P. Therefore, by the SAS rule of similarity, I will get that the triangles are going to be similar. So triangle AMC becomes similar to triangle PNR. If the triangles are similar, will the sides be proportional? So I will get what? I'll get CM upon RN will be equal to CA upon RP. Okay. Now this means CA upon RP is equal to, but CM upon RN was what from the first equation? AB upon PQ. So I get Cm upon Rn is equal to AB upon PQ. That means AB upon PQ from first one was what? Equal to BC upon QR. So I get Cm upon Rn is equal to BC upon QR. Cm upon Rn is equal to AB upon PQ. But AB is what? Twice of Bn, and PQ is what? Twice of Qn. So I get Cm upon Rn is equal to Bm upon Qn. That means Cm upon Rn is equal to Bc upon Qr is equal to Bm upon Qn. Therefore, triangles CMB is similar to triangle RNQ by the SSS rule of similarity. So triangle CMB is similar to triangle RNQ by the SSS rule of similarity. So this is all in the solved example section. We will be doing the exercise in the next session. Thank you so much.